So we've seen pulling the file from the server and then sending it via the response stream. Let's remind ourselves about how we can use streams to improve performance. Let's go back to our simplest example of pulling HTML from the file and just having the contents. And then we read it synchronously and then sent it to the response stream. The problem here is that it's a synchronous call, meaning that what will happen when someone in their browser makes the request, every time someone makes the request, the JavaScript for that particular person running that request will stop, will fill a buffer with the full contents of the file, and then send it all back. That means if this website, if this URL became very popular, we could end up having problems with memory if the file was extremely large. So the idea of using streams is fundamental to improving performance. We've seen that. So how could we rewrite this in order to use streams? Well, it's very simple to get a stream connected, a readable stream, to this index.html file. I just say fs.create read stream. Now, what can I do with a readable stream? Well, remember, streams are just a wrapper around the idea of dealing with data a chunk at a time. So in this case, we're reading a file, but I could send the chunk to any writable stream. And what's the writable stream that I already have available to me? That's right, the response that was passed to me when this event listener, given as a callback, was invoked. So I could actually just, for simplicity's sake, get rid of this variable, get rid of this, and just say .pipe to the response stream. You see what we're doing there? I'll shrink this a bit so we can see it. So we have a response stream, I write to it, and then I say connect a readable file stream and pipe it to this response stream. So every chunk of data read from the file will be buffered and then piped out to the HTTP response stream. So rather than pulling the entire file into a buffer and then sending it, we'll send it a chunk at a time. Our buffer stays small, and that means our application will be faster, more responsive, more performant. It's pretty simple, right? Does it work? Well, let's run our node app.js and go to our local host, and it does. See that? So instead of waiting, the code can just run and start the stream, and as we get a chunk of data from the file, it gets piped out. And since a TCP/IP connection is a stream anyway, is sent in chunks, the browser is already used to dealing with data coming a chunk at a time and then processing it after it's downloaded or even as it's downloading, like you would, for example, in a streaming video. So since streams are fundamental to how the internet works anyway, this works perfectly. Now, what if I had wanted to replace the contents as it goes? Well, I'd need to write a custom stream that dealt with the fact that I might not have the whole string to replace. I'd have to look at the chunk, see what string I have, find where maybe a placeholder starts, and see if it ends within that chunk or maybe ends in the next chunk. But that seems doable. Now, that's not built in to Node.js, the core. But the concept of streams is, and this ability to pipe between different kinds of core streams. So we could build on that. We could grab a full file when necessary, like an image or a CSS file, and just pipe it straight out. Or we could do something fancier when we need to manipulate something, like a template. Make sense? So again, we have the core of something that would take a bit of work to fully flush out. It would be nice if somebody else did that for us, and we'll see that a bit later. But here is the idea, the core idea of using streams to improve performance. Remember this in your real-world Node applications. Use streams wherever you can, and when you don't use them, make sure it's on purpose. All right, let's move on.